So this is Pre-Calculus, Section 1.5. This is the video of our lecture. So we want to understand this notation that's used for function arithmetic. So we have two functions, f and g, where x is in the domain of both f and g. The sum of the function f and g is denoted by f plus g of x. So you simply take f of x and you add g of x and you simplify the result. Likewise, the difference of f and g, written f minus g of x, is simply the difference of the two functions. So you have to be careful here that you distribute the negative to the second function if you have g of x with more than one term. And then the product of f and g denoted just fg, or sometimes you'll see a dot in between them like this, and it'll be written f of g, f times g of x, is simply just the product of the two functions f and g. And then the other one is the quotient of f and g, so that would be f on top, g on the bottom in this order. So this would be the top and g would be the bottom. Alright, so we call that the quotient of f and g of x. F of x on the top, g of x on the bottom. And then the thing we have to watch out for here is our denominator. So we cannot have the denominator go to 0. So we have to remove the x's that cause the denominator to go to 0. So this is the example we're going to do. So we're given two functions. So 6x squared minus 2x, and then g of x is 3 minus 1 over x. And we're going to do these four things here, and I'm going to take it to a clean slide so I have some room. So the first thing we're going to do is find f plus g of negative 1. So whenever you have a number in here, you're not going to end up with a function of x, you're going to end up with a numerical result, because we're going to substitute the negative 1 in and find that final number. Alright, so we've got f plus g here, so we've got the function f, so that would be 6x squared minus 2x, and we're going to add to that the function g, and we're going to get a new function, which is going to be f plus g of x, and that'll equal 6x squared minus 2x plus 3 minus 1 over x. Alright, now we're going to substitute negative 1 in wherever we have an x. So we're going to say 6 times negative 1 squared minus 2 times negative 1 plus 3 minus 1 over negative 1. And that's going to give us a number. So that would be 6 plus 2 plus 3 plus 1. So that's going to be equal to 8 plus 3, that's 11 plus 1 is 12. Alright, so our answer is 12. Alright, so now we're going to find f times g of 2. So that means we're going to take f, 6x squared minus 2x, and we're going to multiply it by 3 minus 1 over x, and we're going to substitute 2 in for x. Now let me just say, you can do this the quick way, or you can do it the long way. The quick way would be to go ahead and substitute 2 in for x at this point, and everywhere you have an x, then just multiply those two numbers together and you'll have f times g of 2. But what I'm going to do is I'm going to show you how to simplify this function, our new function, f times g of x. and then substitute 2. That way we'll get some practice on simplifying something that looks like this. Okay, but just to reiterate, if you just simply wanted the numerical result, remember this is going to be a number because you got to plug in that 2, you could jump to doing that right away. But there are going to be times where we want to actually get the function first. So I'm going to distribute. So first I'll distribute the 6x squared. And then I'll distribute the minus 2x. And then I'll simplify this. So I'll have 18x squared minus 6x squared over x minus 6x plus 2x over x. So I can cancel one of the x's here, this x here. Alright, so then I've got 18x squared minus 6x minus 6x plus 2. That's 18x squared minus 12x plus 2. Alright, so if I want to go ahead and plug 2 in now, I'll get my number. Alright, so that's going to be 18 times 4 minus 24 plus 2. So that's 72 minus 22, so that's 50. So our numerical answer is 50. Now this is our new function here. If we were asked f(g) of x, that's our new function. Okay, on this part of the example, we're asked to find the domain of the difference g minus f of x, and then the formula g minus f of x. So in this example, we're not substituting a number, so we're going to end up with a function of x. So g comes first, so we've got 3 minus 1 over x, that's g of x, minus f of x. So I'm going to distribute my negative. So I've got 3 minus 1 over x minus 6x squared plus 2x. So this, right now, is one form of the new function g minus f of x, but it's not the preferred form, and that's just because of the way it's written here. You've got this piece here written as a fraction, but let's simplify that. Think about it this way. These all, every term is a fraction. If you put a 1 on the bottom, we want to get it in the form of a simplified fraction. So we're going to combine all of these terms and get it with one denominator. Now, we learned how to do this back in Algebra 2, so it's worth going through it right now. So if we want x in the bottom right there, we want to multiply everything that doesn't have an x in the bottom by x over x. The second one, we don't need to do anything to. That already has an x in the bottom. This one here needs an x in the bottom. And this one here needs an x in the bottom. That way, we'll get like terms. Common denominators, better way to put it. Alright, so now I've got 3x over x minus 1 over x minus 6x cubed over x plus 2x squared over x. Okay, so now we have common denominators. Alright, and when you have common denominator, you can combine into one fraction by just writing your numerator out. So I've got 3x minus 1 minus 6x cubed plus 2x squared all over x. Okay, so this would be your preferred way of writing g minus f of x, the new function. Alright, so this is a preferred way. All right. Now, as far as what the online homework will accept, you could try inputting this form of it here before you got it into one fraction like this. Most likely it'll accept this for sure. Question mark on online type of math, you know, software packages, what form they want. You know, sometimes you just have to try it. Okay, but this is what I would want right here. All right, so this is your formula. Now let's look at the domain. All right, so if I'm looking at the domain, I've got a problem if my denominator right here is 0. So we can't have x equal to 0, because if x is 0, then you've got a 0 in the denominator. So x cannot be 0. So if we look at the number line here, x cannot be 0, so it would be empty. But we're over here, okay, and over here. So if we write that in interval notation, that's negative infinity to 0, union, pick up on the other side of 0, 0 to infinity. Okay, so this is our domain. So now what we're doing on this part of the example is we're going to find the function g divided by f of x, or the quotient of g of f of x. We're going to find a formula, and we're going to specify the domain of this function. So if we set up the formula first, let's set up the formula. So g is in the numerator, and f is in the denominator. All right, so let's go ahead and look at where our domain restrictions are going to occur. All right, so in the top here, if you've got a 0 in this spot, then you have a need to take that x value out of the domain. So when x is equal to 0, you've got a 0 in that spot, so that tells us that x cannot be 0. All right, so then we have the issue of this part of the entire fraction could be 0, and if that happens, you got to remove that x value that causes the 0 out of there. So that means that 6x squared minus 2x, wherever that goes to 0, we want to remove the x's that cause that. So you want to factor that first. Take out your GCF. All right, so this one right here, if this factor is 0, 2x equals 0. All right, so that just simply says that x cannot be 0 again. So like in the numerator, so we've taken 0 out completely. Now over here, what causes this part to be 0? So x equals 1/3. So if x is 1/3, you've got a 0 in the overall denominator here. So if I put that on the number line, I've got a no for 0, empty circle, and a no for 1/3. So those two numbers have to be taken out of the domain. So if I'm going to write my domain, I've got negative infinity to 0, union 0 to 1/3, union 1/3 to infinity. All right, so that's my domain there. Okay, now the next thing we want to do is go back and fix our fraction. Okay, so I erased all that domain work. Now, so what I have here is 3. Let's just rewrite this a minute. That's my numerator. That's my denominator. All right, so this is a triple decker. That's what I call them. So I've got one layer, 2 layers, 3 layers. Okay, in order to get that into the preferred form, you just want one numerator over one denominator. So I'm going to fix my numerator. First, I'm going to multiply 3 by some form of 1 so that I can write my numerator as one fraction. So that would be 3x minus 1 over my common denominator of x. Okay, so I'm getting there. All right, so that's 3x minus 1 over x divided by, so this is over 1 here, divided by 6x squared minus 2x over 1. Now, remember when you divide fractions, you want to change it to multiplication and flip the second fraction and then simplify. All right, so now I've got 3x minus 1 over x. Let's see, let's go ahead and distribute it. So I've got 6x cubed minus 2x squared on the bottom. All right, so one more step. Let's check and see if that factor 3x minus 1 could potentially cancel. So I'm going to look for a GCF on that lower piece, denominator. So if I take out a 2x squared out front, that would leave me with 3x minus 1. All right, so you want to check your work here. So 2x squared times 3x, that's 6x cubed. 2x squared times negative 1 is minus 2x squared. All right, so these two pieces here are going to cancel out. All right, so that leaves you with a 1 on top. So you've got 1 over 2x squared. That right there is your function. Let's write it. Your formula for the function, the quotient of g and f of x. All right, so this is your simplified result right here, and that would be correct. If you didn't simplify it all the way, you would lose some points on a test. Okay, the next thing we learn in 1.5 is what is meant by a difference quotient. Okay, so the difference quotient is this formula right here, where you find the function f of x plus h, meaning you substitute x plus h for x, then you subtract f of x all over h, and then you simplify by combining like terms and canceling. So we're going to try this a few times. Okay, we're going to try these examples here. We're going to find the difference quotients for 3 different types of functions. So this one, and this one, and I'm going to take it to a clean paper. Okay, so I've written the formula for the difference quotient over here. So we're going to go ahead and do our substitutions here. So we've got f of x plus h. Oops, let's get a skinnier pencil. All right, so I'm going to substitute x plus h wherever I have an x. Okay, so that's the f of x plus h. And then I'm going to subtract the function f of x. Okay, so this is f of x. I'm going to subtract this whole thing. And then I'm going to divide everything by h. And now it's just a question of doing the simplification. All right, so right here I've got double distributing. Now that's a common mistake, so heads up on that. X plus h times x plus h. We got to double distribute. All right, and then this here is a distribution, so that's minus x minus h, and then I've got minus 2. All right, here's some more distributing here, 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 and here, minus x squared plus x plus 2. All right, so carrying out the double distributing, all right, so we get all of this, and then we'll see where we've got like terms. All right, so let's combine like terms and cancel anything that's exactly the same. So this is going to cancel. X squared minus x squared, those two cancel. Minus x plus x, those two cancel. Negative 2 plus 2, those two cancel. All right, so we're left with 1xh. Okay, wait a minute. 1xh plus 1xh, that's 2xh, plus h squared minus h. All right, so this is all over h. Okay, so recall that this is all over h. So I sometimes go ahead and wait to the end to put that h line back there because it takes up a lot of room to draw it every time. All right, so now I'm going to cross out an h wherever I've got one. So I got 1h, 1h, 1h. All right, so my final answer is 2x plus h. So I got an h here, and then I've got a minus 1. Plus h minus 1. Okay, so this is my answer. This is my difference quotient. All right, and this is something that we need to know how to do. When we get to calculus, we do this a lot because this is how we find the derivative of a function. Okay, let's do it again. We're going to find the difference quotient. So our formula for the difference quotient is right here. Okay, and this is something that we have to know by the time we have a test. Okay, so I've got f, well, in this case it's g. It doesn't matter whether it's f or g. So I've got 2 times x plus h. Everywhere where I have an x, I now have an x plus h. Okay, so that's g of x plus h. Now we're going to do minus g of x. And then we're going to divide by h. All right, so this is going to require some algebra here to get this simplified. All right, so let's go ahead and do that simplification first. So on the top, let's go ahead and see what that is. So I've got 3 over 2x. So I'm going to distribute here. Plus 2h plus 1 minus 3 over 2x plus 1. Okay, now we have this divide by h. But let's just do that last so that we don't have to carry that with us while we're doing this algebra here. Scoot that up a little bit. All right, so what I'm going to do here, I'm going to recognize that I've got a denominator here that looks like this and one here that looks like that. Okay, so I need to get a common denominator, which is going to be this times this. I need both of them in the denominator. So remember, my denominator is going to be 2x plus 2h plus 1. I'm going to have that. And I'm going to have 2x plus 1. That's going to be my denominator. All right, so this one is going to have to be multiplied by, let's put it over here, by 2x plus 1 over 2x plus 1. All right, and then the other one, let's move the h out of the way. The other one is going to have to be multiplied by 2x plus 2h plus 1 over 2x plus 2h plus 1. Alright, so then you can see we're going to have that in the denominator both here and here, and then we'll be able to subtract. Alright, so that means I've got 3 times 2x plus 1 and then I've got minus 3 times 2x plus 2h plus 1. Alright, so let's get that done, and then we'll divide by h. Alright, so that's equal to 6x plus 3 minus 6x. Now, we got to be careful with your distributing here. Minus 6h minus 3. And then I've got 2x. Let's just put this here for a minute. Alright. So now let's see what cancels out here. So this and this are the same. This and this. When I say the same, they're equal and opposite. Okay? So I'm left with only, let's see, one thing left on the top, minus 6h. Alright. So then we've got 2x plus 2h plus 1 times 2x plus 1. Alright, now at this point, let's go ahead and divide by h. Okay, so when we divide by h, we're really flipping and multiplying. Alright, so instead of writing it divide by h, we can say times 1 over h. We're going to cross that out. Okay, so the h is gone in the top. So what we're left with is minus 6. Let's go ahead and distribute that out. So we've got 2x times 2x plus 1 plus 2h times 2x plus 1 plus 1 times 2x plus 1. Alright, so I got minus 6 over 4x squared plus 2x plus 4xh plus 2h plus 2x plus 1. 2x plus 1, yes. 2x plus 1. Alright. Now, if there's any way to combine like terms, we can do that. Squared. So I got a 2x here and a 2x here, so I can call that 4x. Let's just write it down here. So we got minus 6 divided by 4x squared. We said plus 4x plus 4xh plus 2h plus 1. Okay, so that's what we have. And that would be our difference quotient here. Now, you may have thought that that's a lot of algebra. So this is a heads up. If you're planning on going ahead and taking calculus, this is something we do all the time. So if you're not comfortable with this level of algebra, of just simplifying things that look like this, then you want to give that a whole lot of thought so you don't put yourself in a difficult situation. Okay, so one more of these. So we're asked to find the difference quotient again, but this time we have a square root function. All right. So if I want to substitute x plus h for x, that would be square root of x plus h. Okay, so that's this part here. right? And then I'm going to subtract the function. Okay, so let me just try to make sure you guys aren't confused by the notation here. In this case, let's just put an R here. So we're talking about R this time. We're switching up the variables here. All right. So this right here is R of x plus h. And then we got R of x, so it's just x. And then we divide by h. Right? So there isn't a whole lot we can do with this here. So this right here is actually the difference quotient. There's really no simplification that needs to be done here. All right, so let's move right along here. So let's discuss a classic application of function arithmetic in business. So here our independent variable x represents the quantity of items that's produced and sold. So the number produced is equal to the number sold in our simple problems. Okay, so we have little p of x, which is the price demand function, and it tells you how many items you will sell at a given price. Okay, so generally speaking, as price goes up, the number of items you sell goes down. The revenue function, big R of x, calculates the total money collected. So that means how much money do you earn by selling X items at a given price. Okay, so the revenue function is the number of items times the price. All right, then we have the cost function, which is the cost to produce X items, and it usually has a fixed part, like the startup cost or the factory maintenance cost, that sort of thing. And then you have the variable costs, which depend on how many items you make. Okay, so C of 0 is the cost to make 0 items. So if you're making 0 items and you still have some costs, those are called your startup or your fixed costs. Okay, then we've got the average cost function. We call that C bar of x. So you take your cost function and divide it by the number of items produced. And that'll give you the cost of producing each item separately, each item, one item. And then we have the profit function, big P of x. All right, so that's the difference between the revenue, the money you take in, and the cost of production. So R of x minus C of x is your profit function. Okay, so here's a business example of function arithmetic. So in our problem here, a company produces alarm clocks. Production costs are $10 per clock, so this is your variable price, your variable cost, and $2,000 for your fixed costs. So here A says what is the cost function, C of x. So the cost function C of x has got your fixed piece, so your fixed costs and your variable costs added together. All right, so according to our problem statement, our fixed costs are $2,000. And your variable costs are $10 per clock. So that's $10 times X, the number of clocks. So this is your cost function. Next, it says if they sell the clocks for $25 each, what is the revenue function, R of X? So in this particular problem, it's saying that the $25 per clock is basically a simple function. Sometimes these will be more complicated functions for revenue, but they're just saying straight up the clocks sell for $25 each. So what we can say here is that the revenue R of X is simply going to be $25 times the number of items that you produce. So this is a relatively simple revenue function. Okay, so this is your revenue function here, 25x. And sometimes they can be a little more complicated than that. Okay, so now we're asked, at a price of $25 each, what is the profit function P of x? Okay, so profit is equal to revenue, so that's the money you take in, minus the costs. All right, so let's call that big P of x. So we said the revenue was 25x, and our cost from part A, C of x, is 2,000 plus 10x. So that would be 25x minus 2,000 minus 10x. So our profit function is 15x minus 2,000. Okay, so this is our profit function. All right, next part says how many clocks must they sell to break even? Okay, so when we're talking about the break-even point, that means your profit is 0. So 0 profit means you break even. So we're going to say P of x is equal to 0. Right, so in part C, this is 15x minus 2,000. Alright, so we're going to say 15x is equal to 2,000, or x is equal to 2,000 divided by 15. So if you run that through, you're going to get x is equal to 133 1/3. Okay, so this is a number of clocks, and it really, you wouldn't sell a partial clock, so technically it would be 134 clocks it would take to break even. But the way that you'll notice, if you try to enter 133 or 134, it might not like that too much, this online software. So just round to the hundredths place in such a problem, and it'll likely accept that. So that concludes our 1.5 lecture. Go ahead and try the problem set now for 1.5 and let me know if you have any questions.